Hello, my name is Matthew Brown. I have been a science and technology teacher in the Jefferson County School District for 13 years. I would like to talk about problem-based learning and sustainability in STEM education and how these have shaped our sustainability and NASA Hunch engineering programs. I started as a traditional technology teacher, teaching construction and drafting classes at Lakewood High School. I discovered that when students had a say and were empowered to take ownership of their projects, they were more likely to take ownership of their education as well. I challenged students to lead and provide input, and students rose to meet those challenges. I became more of a facilitator in my classroom, interjecting, guiding, providing instruction when necessary, but allowing students to explore and discover on their own. Empowering students in this manner was infectious. I started a PBL-based renewable energy class. We make biodiesel, build wind turbines and fuel cell cars, experiment with solar panels, and complete a personal energy audit, bringing about awareness of personal energy use. Students began showing a real interest in sustainability as it pertained to their daily lives. While they were interested in the different sources of energy, they were more interested in what they could do in their own lives to live more sustainably. We began to explore green building, food production, and sustainable product design. Students wanted to begin solving some of the problems that they knew they were going to face in their future. So within the same PBL model, I started the NASA Hunch engineering program. Hunch, which stands for High School Students United with NASA to Create Hardware, is a program at Johnson Space Center that allows students to build hardware for NASA, which is the design and prototyping program, and or design experiments for testing on the International Space Station, which is the Extreme Science program. NASA specifically asked us to focus our research on plants and microgravity. Within this class, I saw a natural divide begin to take place, as half the students were interested in the design aspects, and the other half really wanted to work more with the plants for the experiment. We began partnering with local businesses like Colorado Aquaponics, the Big Tomato, and Stratasys 3D printers. This gave students the opportunity to work with experts in these fields, much like they would in the working world. So then we started with a small 10 by 12 greenhouse and outgrew it within its first year of operation. We soon learned that researching plants was a time and space intensive process. With the increased interest in our project from NASA and the student body at LHS, we knew we needed more space. Students collaborated with the school construction program to dig the foundation and build the forms, and partnered with local businesses to obtain donations. We held plant sales to raise money and eventually were able to complete a 22 by 30 foot greenhouse. This greenhouse is now the primary residence of the Sustainable Living class. These students built, operate, and maintain the aquaponics systems inside. This greenhouse has not only led to increased research for the Hunch program, but to a garden to cafeteria program as well. This program has put over 50 pounds of fresh, organic, locally grown vegetables into our school cafeteria in its first semester of operation. It has also become a place for us to collaborate with the Consumer and Family Science program and marine biology classes. Meanwhile, the students on the engineering team were discovering that there was no device available for them to put their experiment in for testing in space. So the HydroFuze project was started to design, build, and test a plant chamber in a microgravity environment. Plants just don't grow the same way in space as they do on Earth, and water doesn't act at all like it does on Earth. And none of us had ever been in space. This made identifying criteria and constraints very difficult, and there were a lot of them to identify. This project affords many opportunities to my students, including the opportunity to present their designs, experiments, and research findings to some of the best scientists and engineers in the world. Presentations are a weekly event in my classroom, and by the time they get to the point where they're presenting to NASA, they're feeling pretty comfortable. It has also led to more than 20 students testing experiments in a microgravity environment, and countless others working side by side with NASA personnel and local business leaders. More people have climbed Everest than have flown in microgravity. It is truly a once-in-a-lifetime opportunity. By the time they leave this program, students have learned to collaborate, work in teams. They've developed problem-solving skills and numerous other life and career skills, all while learning to apply the knowledge that they've acquired in their academic classes to real-world problems. The HydroFuze is being funded by CASIS, the Center for Advancement of Science in Space, by NanoRacks and the Hunch program, and will launch to the ISS on April 8, 2015 aboard SpaceX 6. It will be tested for 120 days and returned to Earth aboard SpaceX 7. This experiment is the product of 12 years of collaboration between dozens of teams, classes, and community businesses. It is 100% student designed, built, and tested, and because of that, they all share in the successes and the failures, the heartbreaks, and the celebrations. Thank you.